In this video, we will fix meshing errors and simplify the geometry of a more complex model. We will build on the concepts of the previous video that fixed errors on a simpler model. We will use the automatic geometry editing tools that will speed up the cleaning of the model and discuss what we need to think about when we're using them. Looking at the floor, we can see that a vast portion of the geometry is in the diagonal. So just this entire half, and a lot of the slab edges are also in the diagonal. These types of models are very sensitive to meshing errors and are also very sensitive to analysis errors. Especially if in RCB these models, unless they're cleaned up, can cause a lot of headaches. Basically the analysis can fail. Obviously, cleaning up models such as this in RCB we'll go into that in more detail in other videos. Now, looking at this particular floor, we haven't input any thicknesses and loadings. That will be covered in a separate video. We're just going to clean up the geometry. Selecting the various elements, we can see a very high degree of accuracy has come in. That was needed to draw these elements, the columns, walls, slab edges, exactly where they will be. But if we mesh, we have the high degree of accuracy warning. We'll continue. We can see that even though it was drawn exact in CAD, there's still a few meshing errors that occur when the information is imported into SLB. Now we're going to go ahead and start cleaning these errors up. Now, unlike the simple model, the simple example that we did in the previous video, we're not going to jump in straight away and round off the geometry. So we're going to start using some of these automated geometry cleaning tools before we round off the geometry. Now, why we use these before we round off is that we want these tools inbuilt tolerances to pick up the various structural elements that they're trying to clean up. So if we round off and some geometry is shifted, they might not work as well as they could if the geometry wasn't rounded off. Before we use any of these tools, we will basically do the process manually in one location just so we understand what it does. It's important to understand what they do just in case we have to manually perform this operation at a later time. Also, it should be noted they're not just magic buttons. You can't just press them in sequence and then the model is magically fixed. In some instances they'll be more useful, in others they'll be less useful. The first tool that we're going to use is the Delete Overlapping Geometry Lines tool. So what this does, it will identify where there are geometry lines overlapping and then it will delete any excess geometry lines. For example, on the balconies here we have a geometry line drawn along this edge, which we don't need because we already have this flooded area defined with the perimeter geometry line. So that is one that can be deleted. Again, not so much of an issue in the orthogonal direction, but it was an issue over here. So when we ran the mesh previously, we saw that this whole edge had meshing errors, meaning there's probably a slight offset in the geometry line shown here and the perimeter geometry line. So using this tool should fix up these errors. So we'll see what it's doing exactly, first by performing the operation manually. So let's imagine we set the perimeter geometry line as the master, then it will search inside the master and it will then find that there's an overlap with this geometry line. It will then explode this line, so it will select it, explode. It will search again, find that this particular segment is inside this geometry line, and then it will delete it. So now we only have one geometry line where one is needed. So I'll undo twice just to put this geometry line back in, and then we'll use the automated tool. So firstly we select our perimeter master geometry line, select delete overlapping geometry lines within the selected geometry line, and it exploded 7 of them and also deleted 7. So if we go back to this area, we can see, as we did before manually, this has automatically been exploded now. Selecting over this common area, right-clicking, we don't see the message select line under, meaning there's only one geometry line here. And we should see the same thing here as well. So this particular tool exploded that closed geometry line that used to be here and deleted the double up. The next tool that we'll use is the Fix Wall Gaps End-to-End tool. So it will automatically go through each of the walls, see if there's a small gap between their corners, and it will basically join them up again. If we press Shift-E to show the mesh, we've obviously modified the model so we lose the mesh, but we should still see the meshing errors. This particular meshing error is caused by a small gap, pressing Escape to clear, a small gap between the center line of this wall and the center line of this wall. So what this tool will do, again, it will simply, if we go to the Home tab, set Snap Settings to Snap to Corner, identify there's a gap between these two walls, drag and drop one of them so that they finish at the same point. So Control Z to undo, and it will search through all of the walls and fix up any gaps if there are any. So we'll just run this tool now automatically. So that was the manual process. We will now do it via the automated Fix Wall Gaps End-to-End tool, and we'll say current level, so it will search through all of the walls. It tells us that wall number 44 and number 1 was fixed, so basically only one wall was fixed. If we press Control F to find what wall that was, it was at the location that we said, but the software chose to move the other wall. The next tool that we will use is the Add Geometry Line Nodes at Wall Ends tool. What this is and why we're using it is currently with a high degree of accuracy. If we zoom into this particular area, the angle of this slab edge matches the angle of these walls pretty much exactly. So when we meshed it previously, we didn't see any meshing errors along this edge, which basically the CAD file was very accurate, so the angles matched exactly. So there were no meshing errors. However, when we round off the geometry, the angle of this geometry line segment will no longer match the angle of these individual wall segments, and we'll definitely get meshing errors along these wall lengths, and probably the model won't run. We might get some errors in the walls as well. So before we round off, we will insert nodes at the basically in this geometry line, snap them to the wall ends, so that when we round off, these points are moved in the same position. So the process that we will be automating is simply, if we go to this corner, right click, insert node, drag and drop. So that's the process that will happen, but instead of us doing it basically visually inspecting, doing it wall per wall, geometry line per geometry line, the program will attempt to do it automatically. So hitting Control Z and pressing tilde to zoom extents, we will go add geometry line nodes to wall ends on the current level. So it tells us 41 geometry line nodes have been added. If we zoom back to this area, we can see that all along this edge, the program has added geometry line nodes on the perimeter geometry line at the wall ends. So when we round off, we won't get a whole bunch of meshing errors because everything will be shifted. These 2 points, so the point on the geometry line, the point on the wall, will be shifted in the same direction. And finally, the final tool that we'll use, which may not be so useful in this particular example, but we'll have a look at what it does anyway, is the Add Geometry Line node at Intersection tool. So it works in a similar way to the tool that we just used, Add Geometry Line Nodes at Wall Ends. But what the software does, it will look through the various geometry lines. If they intersect, it will add a node at the intersect location. So if we go to this area, we have the perimeter geometry line. We also have this particular geometry line that is used to define the balcony. Again, if we were to round off this geometry, as we saw in the CAD import video, we may lose this flooded area because this point will shift away from the exact intersect location. So what we would like to do before rounding off is to have a node inserted. So we would manually do it by selecting the perimeter, right-click, and insert node. So we drag and drop to the corner of this intersecting line. Now with that node there, if the rounding operation were to be performed, these points would move together and there would be no meshing error at this location, and we would still keep this flooded area. So we'll undo that and undo again to get rid of the node, and this time we'll use the tool. So add geometry line nodes at intersect on the current level, and 26 additional nodes have been added. So there'll probably be a few here that were added that weren't there previously. Again, not necessary in the orthogonal direction, but they've been thrown in there anyway. And this particular node was added automatically, similarly to how we did it manually just a moment ago. Zooming extents again. Basically, we are now ready to round off the geometry. So we'll probably still need to do a bit of manual tidying after we round off of the model. However, we've reduced a lot of our work by automatically putting in geometry line nodes at the intersection location with the walls, and geometry line nodes at the intersection with other geometry lines. So let's round off to two decimal places. We'd like to keep this geometry looking similar to what it was previously. We see the model has shifted slightly. We'll mesh again, and then we'll tidy up the remainder of the errors manually. Now we may see more errors come up than there were previously, which we do. However, this is to be expected, and it pays to have these errors fixed now, working with a degree of accuracy that the software can handle, or that can handle better than it is to have continued with that very high degree of accuracy. So again, it said 72 errors, but it's just occurring in a few locations. So we'll look at this area first, and we'll simplify it a bit. So rather than modeling this thin piece of slab here, we can just start to simplify the model now and essentially just use the one geometry line. So similar to what the automated tool was doing before, I will manually explode this geometry line and delete on the keyboard to delete the excess lines, including this small segment. This particular edge, for simplicity, I will snap to corner. And this edge, basically I'd like to keep this nice angle, so in this case I will use the extend with mouse and clip tool. Now we can see that when I use the extend with mouse and clip tool, I have basically I have to introduce a high degree of accuracy back into the model. In this case, to keep this at a nice angle, that's what I had to do. I just need to remember that if I'm to re-import from a CAD file again, that if I were to round off my entire geometry, I would lose this information. So ideally we'd like to avoid using the extend with mouse and clip tool on the walls. So we'd like to keep the wall ends to the chosen level of accuracy that we are working with. The reason why we keep the walls to the chosen level of accuracy, again, it's not so much of an issue in SLB, but in RCB it becomes an issue because the walls are essentially the critical element. They run between floors, and we also generate mesh along the wall's height. So general rule of thumb is keep the wall ends at the chosen level of accuracy, and if you have to use extend with mouse and clip in the diagonal, use it on geometry lines only. So this area now should be fixed. It's also been simplified as well. And visually inspecting here, we can see that there's a slight kink in this geometry line, so we'll tidy that up. We will set that as a master and align that to the X. And no meshing errors there, but just to keep it straight. Pressing Shift-A on the keyboard to show the mesh. Despite there being no mesh, it will still show us the errors. Now we'll have a look at these areas. We'll see why the meshing errors were introduced and how we can fix them. So why the meshing errors were introduced? Basically, when we rounded off, we lost some information. So the wall now has one angle, and these geometry lines that are sort of sitting on top of it basically have a separate angle. Now, how we will fix this up? Again, we'll use the extend with mouse and clip tool. Basically unavoidable in this case, and we will clean up these errors. So we want to get rid of this node. So here is one example where the automated tool of adding a geometry line node at geometry line intersect had some undesirable consequences. When it was added, it was probably the exact location with a high degree of accuracy. However, when we round it off, it is now in an incorrect location, hence why we have many many closed node meshing errors along this wall length. So to tidy it up, we will get rid of one of the nodes. So right click, remove node. We will then change the snap settings to snap to grid and just move this line some distance away. We can see we've got one extra node there as well. We'll remove that as well because we don't need it. The reason why I'm moving it away is because I'm about to do the extend with mouse and clip operation. Now I want this particular line to be clipped to the wall center line. I don't want it to be clipped to this geometry line. So we already knew from the very fact that there was meshing errors that there was a slight difference in the angle between the geometry line when it was sitting on the wall and the wall itself. But now we ensured that we clipped this perpendicular geometry line to the wall center, which we are using as the reference. Change snap settings to snap to corner. We simply snap this geometry line edge back to that location. Now there is no need to put a node in here because we've already got this high degree of accuracy from the extend with mouse and clip operation. Similarly for this end, we will change the snap settings to snap to grid, drag and drop away, right click, hover over the node, right click, hover over the node, right click. It looks like we've got a double node there, that's why it's not letting me set as master. I will remove one node, extend with mouse and clip. So again, we've put in the high degree of accuracy to get that exact intersect location. Change the snap setting back to snap to corner, drag and drop. So now we should have fixed all meshing errors along this wall's length. And we repeat the exact same process here. Now, because this geometry line wasn't exploded in the various automatic operations we did, rather than extending and clipping, we can simply change the snap settings to snap to edge. So we just drag it across, drop it down, and basically that's the level of accuracy it needs to snap to that wall end. So this should fix all of the errors along this wall's length. Now, another option would have been to segment this wall, so keep the degree of accuracy of the geometry lines at 1 or 2 decimal places, and then basically snap the walls to these locations. However, the downside of that is basically we're just making this wall element softer. Again, SLB, it doesn't cause that much of an issue, but if we're modeling in RCB and this is let's say a major element that's contributing to our lateral resistance, it is an issue. I'll quickly show you what I mean by that. So going to this next span, and the coordinates of these geometry lines are at 1 or 2 decimal places, which is what we rounded off to, and these walls are at a slightly different angle because of the rounding operation. So changing snap settings to snap to corner. The other way to do it would be as so. So we've got basically 1, 2, 3, 4 wall segments that match the angle exactly of the geometry line. This wall spans from geometry line node to geometry line node, this one to the various geometry line nodes as well. Now each option has their pros and cons. This option we've kept everything to 2 decimal places, so it's a little bit easier to work with. However, the downside is we've segmented our wall. This option here, we've kept the wall in one piece. However, to keep this geometry, we've had to use extend with mouse and clip and use a high degree of accuracy. So again, depending on which software we're using and how important this wall is for our lateral capacity, or depending on what type of, whether it's going to be a brick wall, a reinforced concrete wall, either option may be more suitable. But definitely this option here on the left is the one that's easier to work with. So we'll just do that again for this particular segment. So we'll pull this back, draw a wall again, now the geometry here is starting to get a little bit intricate, so we'll go ahead and start tidying this up slightly. So we'll remove this node. We'll pull these wall ends back to the intersection with this wall. And this geometry line, again, we'll just snap it to the to this new location that we've got here. Now there's a big difference in the angle of these walls and this geometry line. There'll definitely be errors here based on what we just did. So we will put a node in here, insert node, drag and drop, and get everything running through the center line of the wall. So again, we've sacrificed accuracy, as it will be built, to get it to something that to get it to a level that the software can handle. So this has all been tidied up. Let's zoom extents, remesh, and let's see what we've done. Excellent, no meshing errors. So again, summarizing the changes that we did, we simplified the model in some areas to get it meshing. We used the extend with mouse and clip tool on geometry lines when needed. In this particular area, we kept the wall, basically we didn't segment the wall, we kept it as one piece, and then we used the either snap to corner or extend with mouse and clip on the intersecting geometry lines to make sure that they all sit exactly on the wall's center line. Or alternatively, we kept the geometry lines where they were, rounded off to the chosen degree of accuracy, and then we segmented the wall, and using snap to corner we just ran the wall to the various geometry lines, ensuring that the angle matched. So in both cases, the angles of the geometry line and the wall match. The difference is we have one wall compared to 1, 2, 3, 4 walls now. Now, with all of the meshing errors fixed, we can go ahead and keep working on the model and continuing our design. Now, a summary of the key concepts from the last few videos. All of these concepts are also applicable to RCB and PTD. You may have noticed a common theme in the last few videos has been rounding off of the geometry. Choosing a suitable degree of accuracy, so 1 or 2 decimal places, makes the model much easier to work with. Now, the program lets us use a much higher degree of accuracy, but that doesn't mean that we should. The model will be much more sensitive to meshing errors and much more sensitive to analysis errors, and it makes it much harder to work with. So rounding off may seem like more work initially, but in the long run it will be much quicker because we don't have to keep chasing our tail trying to fix analysis errors. Another key point to take away from this video is don't use finer mesh to fix errors. Often we will be hiding some errors by using finer mesh, and we are unnecessarily increasing the runtime. Now, if the model is in the diagonal direction, use the automated geometry editing tools before rounding off to reduce manual cleaning of the model. But it's also important to understand what the geometry editing tools do, so that if we have to perform those operations manually, we can do so. Another key point is only use one geometry line where one is needed. So this makes the model lighter, simpler to work with, and there are less locations to fix errors in. Another key point to take away from these videos is after rounding off, if a high degree of accuracy has to be reintroduced into the model, try limit this high degree of accuracy only to the elements that will be on the slab zone itself, so the geometry line and the beams. Vertical elements that span in between floors, such as columns and walls, we'd like to keep them fixed to the chosen degree of accuracy that we rounded off to. So this is not so much of an issue in SLB, but becomes much more of an issue in the RCB software. More on this in the next videos. This concludes this video. Thank you for watching.